Welcome to the FLUIDOS Node Edge IoT demo. The figure illustrates the complete system we will deploy. Two containerized FLUIDOS clusters, a consumer and a provider, will run on the same machine. The provider cluster supports Edge IoT through Cloud Core at the cloud and Edge Core at the edge, enabling low-end devices to join the Kubernetes-enabled FLUIDOS cluster as worker nodes. Combined with the mapper component, these elements facilitate communication with far-edge devices, allowing data retrieval and forwarding, e.g. sensor values. Although this environment is emulated, we have arranged all components, cloud, meta, deep, and micro edges, in a hierarchical structure similar to a real-world scenario. After setup and configuration, you can access InfluxDB via an SSH tunnel in your web browser. We create a test bed using an automated script that employs an enhanced version of Kind to provision two clusters, a provider and a consumer. The consumer cluster includes a control plane and two workers. The provider cluster includes a control plane, one standard worker, and one edge worker. The script uses Helm to deploy FLUIDOS Node components and finally installs Lico for cross-cluster peering. We then verify that all FLUIDOS components are running and that all nodes in both clusters are ready. FLUIDOS Edge components are not managed by Kubernetes. Next, we enable deployment offloading from the consumer cluster to the provider cluster using a namespace named demo. Next, we establish an SSH tunnel to access the provider's pods on port 886 and then verify the connection. Next steps include offloading to the provider's cluster the following: 1. InfluxDB database. 2. Telegraph, which is a server agent that makes it easy to collect metrics, logs, and data to InfluxDB. And this figure depicts the progress made so far, where we have the two clusters. As seen, Provider Cluster enables Edge Worker nodes via Cloud Core and Edge Core components. Next, we power on the STM32N node and connect it to the same host where the clusters are deployed. We will interact with the N node over Bluetooth. Initially, we discover the node's MAC address before we are able to register the device. Next, we run the custom Edge Resource Manager module. This module discovers Edge Worker nodes, micro-edge devices, aka N nodes, and their attached sensors. It will be implemented as a FLUIDOS node module capable of creating sensor-type flavors during the third year. Next, we deploy the Bluetooth mapper. This module will pair to the N node device based on the configuration and forward sensor data to the provider's control plane. As seen, no data is stored to the database, and this is normal since no proper configuration has taken place. For this, we deploy the router manager that will create a data link between the router, a Cloud Core component, and Telegraph. Router manager will be implemented as a FLUIDOS node component, able of creating such links during sensor resource reservation during the third year. Once the data link has been successfully established, sensor data sent over Bluetooth by the N node finally reach Telegraph that subsequently stores them to the database.